Welcome friends to my channel. Here I am going to discuss the GATE syllabus, and I am starting from analog electronics, analog circuit, and the topic is OPAMP, and question is from IIT Bombay, asked in 1987. The question is, in figure, if the CMRR of the operational amplifier is 60 dB, then the magnitude of the output voltage in millivolt is what? So here the circuit is given. So this is the bridge circuit. In bridge circuit, one input of the op-amp is connected to this point and another input is connected to this point, and it is being, all the resistance values are given, and it is being asked what is the value of output in millivolt. So solution, first we will see the sum of the terminology of op-amp. So let me see here one model where V1 and V2 are the input voltages and output voltage is VO. So there are two models. One is V1 and V2 are applied to two different gain, and the output is sum of these two. So A1 is the gain for this, A2 is gain for this V2, and we'll get VO is equal to here A1 V1 plus A2 V2. This is the first model. And second model is this one, where the differential voltage is applied and its gain is differential gain AD, and differential input common input voltage is VC and its gain is AC, and the sum is output is the sum of these two. So output can be written as AD VD plus AC VC. So we can define VD, or VD is defined as the difference of these two input voltages V1 and V2, which is equal to V1 minus V2, and VC, which is common mode voltage, is defined as the average of these two voltages V1 and V2. So VC is equal to V1 plus V2 by 2. By calculating back from these two equations, we can get V1 and V2 in terms of VC and VD. So V1 we can get as VC plus VD by 2, and V2 we can VC minus VD by 2. Now VO from first model is given at A1 V1 plus A2 V2. We can put the value of V1 and V2 from these two equations, and we will be getting this equation. Okay, so here we can rearrange this equation, and when we can find the equation in the term of VT and VC, where the coefficient is nothing but AD and AC. So by comparing, we can get AD is equal to A1 minus A2 by 2, and AD is equal, AC is equal to A1 plus A2. And again, calculating back from these two equations, from this equation and this equation, we can find A1 and A2 in the terms of AC and AD. So A1 is equal to AC by 2 plus AD, and A2 is equal to AC by 2 minus AD. Now coming to the question, in this question, here 2 volt is supply voltage, and R1, this R and this R in a series. So from voltage division rule, this voltage is V1. We can find V1 is equal to R by R plus R into 2 volts, which is equal to 1 volt. And again, this R in series. So V2 we can calculate from this equation, R by R plus R into 2 is equal to 1 volt. So V1 is equal to V2 is equal to 1 volt. Now we can derive AD, differential gain, for this general circuit. So general circuit is just similar to this, only we are keeping this R1, R2, this is R3 and R4. Now we can apply the superposition theorem. First, we will use V2 is equal to 0, and only V1 is applied, and output is VO1. So V1 is equal to, because V1 will be applied to the non-inverting terminal, so gain is 1 plus R2 by R1 in V plus, and V plus is this voltage. So V plus we can find in the term of V1 from voltage division rule. So V plus is nothing but R4 divided by R3 plus R4 into V1. Putting this back into this equation, we can get VO1 is equal to R4 by R3 plus R4 multiplied by 1 plus R2 R1 into V1. So second case, we are taking V1 is equal to 0. This is not present, only this is present, V2, and the output is VO2, and VO2 is nothing but, because it is applied in inverting mode, so gain is minus R2 by R1, which is VO2 is equal to minus R2 by R1 into V2. Now third, we can put VO is equal to VO1 plus VO2. From this two equation, we are getting this expression. Now we can find a special case if R2 by R1 is equal to R4 by R3, means it is balanced. R2 divided by R1 is equal to R4 divided by R3. In this case, special case, we can rearrange VO as from this equation. If you divide numerator and denominator by R3, we will get this expression. Now putting the value of R4 by R3 equal to R2 by R1, we are getting this expression, and rearranging, we can see these two are cancelled out. We are getting R2 by R1 V1 minus R2 by R1 V2. So VO is nothing but R2 by R1 V1 minus V2, and this is nothing but the differential voltage VD, and this is AD. So we can find AD is nothing but R2 by R1. Also we can find from this expression VO is equal to A1 V1 plus A2 V2. So A1 is nothing but R2 by R1, and A2 is nothing but minus R2 by R1. Now from the formula of AD, we can find A1 minus A2 by 2. So AD will become R2 by R1. So we can get AD from both way, from this way or this way. And AC is A1 plus A2, which we are getting 0 here. Now AC will be 0 for ideal op-amp. Ideal op-amp means noiseless op-amp. But if noise is present, then AC will not be equal to 0. However, AC will be negligibly small. For this question, V1 is equal to V2 is equal to 1 volt is given. So we can find VD is equal to V1 minus V2 is equal to 0 volt, and VC is equal to average of these two voltages, so which is equal to 1 volt. Now VO can be given from this second model, ADVD plus ACVC, but VD is equal to 0, so we can get VO is equal to only ACVC. But we have VC 1 volt, we need to find AC. Okay. Now to find AC, we have the equation of CMRR AD by AC. So where from we'll get AD? So AD we have derived just now. AD is equal to R2 by R1 if R4 by R3 is equal to R2 by R1. So from this question, it's given 100 kilo ohm. Here we can see 100 kilo ohm. 100 kilo ohm by 1 kilo ohm is equal to 100 kilo ohm by 1 kilo ohm. It is balanced. So we can apply this equation here to derive the equation for AD. So AD is equal to R2 by R1. We can apply here, which is 100 by 1 value of 100. So we can find the value of AC, mod AC, which is nothing but 100 divided by 1000, which is equal to 0.1. Now put the value of AC and VC in this equation, we will get VO is equal to AC, VC is equal to 0.1 into 1 volt, which is equal to 0.1 volt, which is equal to 100 millivolt. So the answer is 100 millivolt. So thanks for watching. Please subscribe and like my channel.